Then, of course, there's the other aspect. We talked about machines, now we have with humans. So human identity is changing as well, which means in the end, even we humans are getting much, much more digital. In addition, so there are spare parts like artificial organisms that are coming into our body. And again, we need to have an identity, an audit trail. Can we trust the organism that's being implanted? And of course, when it's being meshed together, it's again fusion of technology, biological sphere, human, with the brain link, artificial intelligence, cloud computing, that's changing our identity as well. In addition, it's another technology, Pandora's box, CRISPR-Cas, where you do gene editing. Yeah, you can put a string of a gene, you replace it with another string of gene. Extremely powerful, extremely important when it comes to healing cancer, for example, on a very individual level.
The difference of this fourth industrial revolution is it doesn't change what you are doing. It changes you. If you take genetic editing, right. Just as an example, it's you who are changed. And of course, this has a big impact on your identity. Yeah.
I now have the great pleasure to announce Stefan Oehlrich. He's member of the board of management at Bayer, and he's also president for the pharmaceutical section of Bayer. Stefan, please come up. You don't have to wait.
And for us, therefore, we're really taking that leap, us as a company, Bayer, in cell and gene therapy, which to me is one of these examples where really we're going to make a difference, hopefully, moving forward. There's some, ultimately, the mRNA vaccines are an example for that cell and gene therapy. I always like to say, if we had surveyed 2 years ago in the public, would you be willing to take gene or cell therapy and inject it into your body, we would have probably had a 95% refusal rate. I think this pandemic has also opened many people's eyes to innovation in the way that was maybe not possible before.
And again, you're changing identity of people, and in addition, it's worth to know you would like to have an audit trail, let's say it's a little bit gene string, that you're incorporating another gene. Can I trust it? Yeah? Can I really trust it? Does it deliver the promised kind of improvement? Again, that's linked to our human identity.
And offer certain kinds of possibilities that have to be careful about. You know, when you began to do that kind of gene editing, some people worry that you were changing what it means to be human.
That's the problem. And of course, the new industrial revolution offers us many opportunities, but it raises manifold questions on the ethical, but even legal implications. And we have to be prepared for it. And that's what we want to do in Davos next year.
Why not talk about this a little more first? I mean, just as soon as you start talking about it, things get kind of out of crazy. So why didn't
we are talking about it.
Well, we were talking about it, but you have already made it clear that you're going to, I mean, you have said you're going ahead and raising money and doing it.
Well, actually, full disclosure, I've been doing this since 2009. Building human genomes. Part of the reason we developed the CRISPR is because we had an NIH grant to engineer human genomes in cells and turn those into organs, right? So we've been doing it. The question is, what does first mean, right? We've been talking about germline modification for longer than we've been doing CRISPR. It comes up again when
let's just talk. Explain what germline modification is, and just really.
It's essentially what we're talking about.
Yeah.
Is changing not just our bodies, which is gene therapy, our adult bodies, but changing the inheritance of that. So we essentially do gene therapy on ourselves and our children and our grandchildren.
So it gets passed down. So you can make a change in an embryo, and that embryo will grow up to have the trait that you changed and then pass it down. How we might ethically edit ourselves for climate change, for example.
People think we should go forward, anything goes. People should have the liberty to be able to, create whatever kind of human beings or even human animal chimera that they want. Et cetera, et cetera. With this ability to synthesize human genome, we can actually do a lot of things. So a lot of people are worried about, when they talk about moral enhancements, they're worried about sort of, they see it as a zero-sum game, right? If somebody is smarter, then that's going to hurt my child or something like that. But there's actually a lot of opportunities for this to solve big world problems. So one thing is the climate change. And there, I'll just use, sort of climate change is a really big problem. We don't really know how to solve it. But it turns out that we can use human engineering to help us address climate change. So I'll give two examples. So one is that people eat too much meat, right? And if they were to cut down on their consumption on meat, then they would, it would actually really help the planet. But people are not willing to give up meat. Yeah, some people will be willing to, but other people, they may be willing to, but they have a weakness of will. They say, wow, this steak is just too juicy. I can't do it. I'm one of those, by the way. So, but so here's the thought, right? So it turns out that we know a lot about, we have these intolerance to, for example, I have milk intolerance. And some people are intolerant to crayfish. So possibly we can use human engineering to make it the case that we're intolerant to certain kinds of meat, to certain kinds of bovine proteins. And there's actually analogs of this in life. There's this thing called the Lone Star tick, where if it bites you, you'll become allergic to meat. I can sort of describe the mechanism. So that's something that we can do through human engineering. We can kind of possibly address really big world problems through human engineering. Another example is,
you go first.
Yeah. And another example is and here I'll go first, right? You'll see that I'm the smallest person here, right? And Amy's the smallest person. So it turns out that the larger you are, think of the lifetime sort of greenhouse gas emissions that are required to the energy that's required to transport larger people rather than smaller people, right? But if we're smaller just by 15 centimeters, right, that's a mass, I did the math, and it's about mass reduction of 25%, which is huge. And 100 years ago, we were all on the average smaller, exactly about 15 centimeters smaller. Right? So think of just the, lifetime greenhouse gas emissions if we had smaller children, right? And so that's something that we could do through some sort of human...
Could we, setting aside should we, for a second, let's just set that
Sounds
aside.
like there's a Randy Newman song in here somewhere.
But, is that could we actually... Is that crazy? I'm going to ask Drew.
Well, how small should we go?
We shouldn't be so small that we get eaten by cats, right? That's